Guys, I'm going to discuss about this problem here. So let's consider this problem. Let a sub n be this is a sequence of positive numbers such that sum of cubes converges, right? We have to show that the sum of a sub n divided by n squared is convergent. So let's try to show this question, right? Here we know that the sum of cubes of an is convergent, which is this sum is finite, right? So that implies the limit of cubes goes to 0 as n tends to infinity, right? What does it mean? So yeah, then there exists a natural number called, say, capital N, right? Let's erase that. Delete this. Alright. Let's say there exists a natural number n, capital N, such that capital N greater than or equals simple n implies a sub n cube less than 1, right? That means a minus a sub n cube is positive for all n greater or equal capital N, right? So this is a positive value. So 1 minus a sub n cube is equal to, we know this one, 1 minus a n times 1 plus a n plus a n squared, right? So both are the same. So this a n is positive, these are positive numbers, so this part is positive, right? This one is greater than 0, and this should be greater than 0 because this one is positive for n greater than or equal to capital A, right? So we showed that 1 minus a sub n is positive for n greater or equal to n, capital N, right? So that means a sub n less than 1 for all n greater or equal n, right? And we know these numbers are positive, right? So if this is true, then this step is obvious. A n greater squared less than 1 over n squared for all n greater or equal n. That means we can consider the sums of both sides. Sum from capital N to infinity, a n over n squared less than sum from capital N to infinity 1 over n squared, right? So we missed terms from 1 to capital N minus 1. We can add that. Finite terms we have, so we can add that terms also, right? Right, we can add that terms. Let's add that terms. So what are the rest of terms? So n goes from 1 to n minus 1, right? A n over n squared plus this thing plus the remaining terms from n to infinity, right? And so you know this is a finite sum, so this is a constant. So let's add that thing to other side. From n to 1, n minus 1, a sub n squared, right? So this one is a constant and this one is convergent. So this here, if you combine these two summation mark, then you can write n goes 1 to infinity a sub n over n squared. So this is convergent. This one is a finite number, a constant, and this is finite. That means this series, infinite series, is convergent. That one, this one, yeah. This, yeah, delete, yeah, this one, this series, this infinite, oh sorry, that infinite series is convergent.